The motivation for this question is scientists observed these tiny particles that are called muons, and when they built them in the lab, the muon would decay crazy fast. Uh, but when muons were created in the upper atmosphere by incoming light energy interacting with our atmosphere, these muons that were created were flying towards Earth, and because they were moving so crazy fast, they lasted a lot longer before the same decay process would happen. So there is a logic to why I made this weird question up. Um, but if we just apply special relativity to this, um, it's all about the ratio. So they seem to be lasting for 60 microseconds when they're moving compared to 3 microseconds when they're not moving. That's a ratio of 60 divided by 3. That's a ratio of 20. So by that kind of logical step, that tells us what the gamma factor is. So we know that 20 is equal to gamma, and gamma is that crazy 1 over, I'm going to write it this way, v over c squared, all under the square root. We know what c is, so we can rearrange, we can solve for the v. It's totally up to you how you do it calculator-wise. Because I tend to leave my calculator to the end, I'm not going to bother putting in the 3 times 10 to the 8 right away. To solve this one, what I would do is I'd flip things around, get that off the denominator by multiplying it, kind of like a cross multiply thing. Bring this ugly square root to the other side by multiplying it up here. Bring the 20 by dividing it to the other side. So I would get something like 1 minus v over c all squared is equal to 1 over 20. And then to get rid of that square root, I would square both sides. So I would have 1 minus, and actually I might as well write it this way, v squared over c squared equals 1 over 400. Flip-flopping things around, v squared over c squared equals 1, take away 1 over 400. Oops. That means that v squared over c squared equals 399 over 400. Or if I go a little bit more, v squared all by itself is 399 over 400 multiplied by c squared. To get rid of the square, I'm going to square root both sides. So v is the square root of 399, whatever that decimal is, we'll need that eventually, divided by the square root of 400. That's 20, multiplied by the square root of c squared is just plain old c. If we leave it that way, we can finish the question by saying that the object is going at, getting out my calculator, to 3 decimal places, I'm getting 999 times c. We may want to go a couple more just to differentiate where that first non-9 is. I think it happens after the third 9. Or if we put in our values, multiplying 3 times 10 to the 8 by that 0.999 number, I got 2.996 times 10 to the 8 meters per second. And there we go. If we know our 2 times, or if I gave you 2 lengths or 2 masses, based on the ratio, that tells us gamma, and we can use that gamma to solve for the speed.